Thank you everybody for coming. My name is Jonathan Varkovitsky, and today I want to talk to you all about tuning Tableau Server with an emphasis on performance best practices. Before we get started, really quick, how are people liking conference so far? Awesome. All right, before we get into the content, I want to do a couple introductions. First, I want to get to know you all, my audience, what kind of Tableau users you are. Then I'm going to tell you a little bit about me. And just so you know, I do a lot of hand raising with questions. So my first question is, how many people like answering questions by raising their hand? Can I see a show of hands? I see a lot of hands. How many people do not like answering questions by raising their hands? I see one hand up, and that's a very interesting response, by raising your hand. All right. How many people here would say you're a power user kind of in that desktop sense, like making dashboards, doing analytics? OK, I see a number of hands. Excellent. How many of you would call yourselves a Tableau admin? All right, I see tons of hands. Excellent. How many of you do some work that's like an IT admin of some sort? OK, great, about a quarter of the room. And then finally, how many of you are some sort of business leader making decisions about how we want to use data in our organization? OK, about a dozen hands. Awesome. My next question is, with those four groups, how many of you are more than one of the above? Awesome, most hands. And now for the real challenging question, how many of you are all of the above? I see one hand. Excellent. So as we go through kind of some of the methodologies I'm going to talk about for detecting performance and making changes, the reason I called out these different areas is that you can't always do it alone, and you don't always necessarily know what's happening between all these different areas. Now I want to tell you a little bit about who am I. So as I said, my name is Jonathan Varkovitsky. I'm a product manager at Tableau, and I've been around for quite a while. When I joined Tableau, we had just shipped an awesome new version called Tableau 7. Has anyone here used Tableau 7? Maybe, I see 10, maybe a dozen hands. So there were some awesome new features that I want to tell you about from Tableau 7. Some of those included data server, so you could publish your extracts and share them with other people. Now, compare that to Prep Conductor that we just saw this morning. And we had a whole new mark type that was really exciting called filled maps. Imagine that not long ago, that wasn't even something you could do. So when I first joined Tableau, my role was doing server performance testing. So every day from development, I would get a new version of Tableau Server with the latest bits. And I was testing to see how many transactions per second can we do, how fast are single interactions, kind of trying to measure that user experience and get feedback to the feature teams same day, and if their changes made things better, worse, if an optimization did what they expected. I liked that so much, I decided to go into a customer-facing role where I started working with enterprise customers when they were having performance problems. And as I saw before I started, one of those customers is here today. After doing this technical role for about 2 years, digging in on logs, I decided to really jump out of the frying pan into the fire. And I'm a product manager who's in charge of customer escalations in development that are getting any sort of code fix when things are going wrong. So it's really a unique world to live in, seeing how all of our customers are really pushing Tableau to the limits and then helping them move past them. All right, let's dive in with the motivation for the talk today. I've heard from many customers, and many of you have maybe said this to yourselves that, and this usually happens on Monday morning, we came in, it got slow, and nothing changed. And that's the motivation that I want to start with, is how do we address that question, and maybe the fact that something did change, and maybe it was something that we didn't know about. Again, remember I was asking how many of us were Tableau admins versus IT admins or power users. You could have things changing underneath you like the hardware, but as the Tableau admin, maybe you weren't made aware of that because that's happening for your whole company's IT. Or maybe there was a change in your VM system. So I really want to encourage you, as we talk about these options, to think about the other departments in your companies that you should really bring in while making decisions and trying to improve the Tableau experience that you have. So the first question is, how are these performance issues even brought to your attention in the first place? So there's two main ways we hear about things. The first one is what I call user-based reporting. This comes in via red bang emails and Outlook or repeated phone calls to your desk. And this is users who are having a change in their experience. That workbook that's really critical for the CEO, that's underperforming, or the site for accounting is underperforming, or even the entire server is just not performing where we want it to be. The next category, like system level reporting as I call it, is usually something that's coming in that you're seeing as the admin or as the IT admins. With third-party monitoring, you have system resources spiking, you see some Tableau processes restarting in the background, and you're concerned. At this point, we have kind of a mystery on our hands where it got slow and nothing changed. So we want to have a suite of tools that we can use to start digging in and investigating, well, what did change? What are the performance characteristics of our server? And then once we have a feel from there, we can make decisions with a series of knobs that we can control, which I'll be talking about in the second half of my talk, to try to improve that performance. So the first, I'm going to be speaking about 5 tools. The first 2 are going to be kind of OS-based, so they come as a part of your operating system tools. And then the last 3 are tools that were created by Tableau for Tableau. So the first tool, I think everybody's going to be familiar with, is Task Manager. Can I get a quick show of hands? Who's used Task Manager? Excellent. I see every hand go up. We've all hit Control-Alt-Delete, be it on an enterprise server or on our own laptop to just see what's going on and why is something going slow. It's available on all Windows machines since 1996, released on Windows NT 4. Quick aside, Tableau no longer supports Windows NT 4. Please upgrade, talk to your IT admins as soon as possible. And to give you a feel for how long ago that was the same year that Ethan Hunt joined us in Mission Impossible 1 on the big screen. So it's been a while. So this tool is something in all of our toolboxes. You get a quick snapshot. We can quickly go and see what's the worst offender. In the example here, I was starting up Tableau Server on a machine. You can see my CPU is pegged while it's starting all of the new processes and filling and getting started, and you can see the memory dipped and is on the way up. This is great for a snapshot, but really the only way to share the information here is what I actually did in PowerPoint, was I did something and I took a screenshot. So it's not very good for saving. We can't really maintain a history. It's only good for short-term, instantaneous what's going on. And as I said at the keynote, about a quarter of our new server installs are on Linux, and any Linux admin is thinking, I can't use Task Manager, and you're right. So just as a quick aside, you could use the command line tools top or htop to get roughly a similar output as what you see here, and with a richness of Linux, there's probably hundreds of other options and commands built in right there. Let's go ahead and dive into a tool that's a little bit more deep. So the tool is Perfmon. And so this is a tool that, again, runs on a single computer, but you can actually get a really rich history. There are hundreds, if not thousands, of options of what to record. Here in this example, I did CPU utilization in red and available memory in blue. But if you want to have values as fine-grained as the disk queue length on your system or available bytes of virtual memory, all of those can be recorded by Perfmon at any frequency you want. You can even output the results to a table for later. It's really great. You can share those files that are saved. You can have it run indefinitely and even drop log files every set number of hours to your disk. So it's really the first step to having a long-term tool in place. For those Linux users out there, you might want to take a look at the System Activity Reporter, again, giving you a little bit more richness in your monitoring, again, tied to a single machine. I did want to add, just because I like giving a little history of things, that Perfmon has been around since 2006. So again, all of your servers are probably running on a version of Windows newer than that. And back in 2006 was actually a very, very sad year. That was the year that the International Astronomical Union decided to demote Pluto. And subsequently, that was the year that I canceled my membership. And if they would like me to rejoin, they know the one thing that they have to do. All right. So now moving on from tools that are built into the operating system that we might be familiar with, I want to start talking about the first tool, Tabmon, which was created by Tableau for Tableau. So Tabmon, under the hood, is using a similar technology, or it is using Perfmon. Sorry, not similar. It is using Perfmon to do monitoring. But the advantage is you can actually go and install Tabmon on many different machines. So if you have a multi-node environment, you install Tabmon on all of them, and they report all of their results to a single Postgres table. And I do want to quickly make an aside that that's not the built-in Postgres table that is underlying Tableau. That would cause a perf problem by monitoring for perf problems. So you could have it writing to your primary, but you could also have it writing to a machine on the side of your deployment that's not even involved in Tableau. We also have a couple of hooks that are built in, so you can connect events that happen within your resource utilization to events that are happening in Tableau Server. So when is your backgrounder triggering? When are other major system events happening? How do you correlate that to your CPU spike? Because that's how we make steps in our investigation. Another great thing is the tool is open source. So you actually download it from the link here. And I'm going to leave this up here for just a second if people want to get that URL. Now, the one thing I do also want to say, in case people don't want to grab their phones, my deck will be made available a few days after conference with all of the links. Some of the links later in the talk are quite long and not good for writing down, so they're embedded as URLs directly in the slides. So it is open source. Now, as I mentioned, Tabmon is saving all of this to a single Postgres table. And we at Tableau thought long and hard. So we have all of this data. It's in a nice relational database. What's a good way to represent that data? And we came up with a great idea. We use Tableau. So we provide workbooks that connect immediately to that data. And since we picked the initial settings for Perfmon, we have the ability to know what information is going to be shown. So in the example behind me, we are looking at CPU utilization in that top pane over time. And we see a bunch of spiky behavior. And maybe you noticed that in Task Manager or in Perfmon before, but now we see it broken down by process. And because of some of the hooks in Tabmon, we see, well, that dark blue line is backgrounder. Now, if I look closely, those spikes in backgrounder, yeah, they take about 10 to 15% of CPU. That's not marginal, but it happens every hour. Now, just people can shout out, what does backgrounder maybe do once an hour on the hour? So I heard several people. So it refreshes extracts. We're running subscriptions. So maybe initially we were alarmed that we saw the spiking CPU behavior all through the day, kind of regular, but now it makes sense. And we can make a decision based on that. Later in my talk, when I'm talking about some of the knobs we can turn, isolating backgrounder is one of the first recommendations that we have. So if you see a behavior like this, we now know it's not some amorphous CPU is spiking what's happening. We know what process is causing it, and then we can make an informed decision about what we want to do next. So the next tool I actually want to talk about is frankly one of my favorite ones that I'm going to be talking about today. And this tool is called Logshark. How many people here have used Logshark in one way or another? All right, I see a dozen, maybe a dozen and a half hands. So Logshark is a great tool. And at the core, what it's doing is we turned zipped Tableau logs into dashboards. So you can, anytime that you have zipped logs, you can feed them into Logshark, and it creates a whole host of dashboards that are measuring different metrics about the product. So what's your viz load like? How long are viz loads taking? What's your backgrounder traffic like? What are the worst times? So these are similar to what you maybe have seen in your admin views, but the thing here is you can pipe in as many logs as you want. You can compare different times very easily. So for example, if you're going to upgrade server this weekend, take a week's worth of logs, save them on the side. After your upgrade, go ahead and put another week's worth of logs into Logshark together and see how are things before and after. Are things improved? Are things doing what I was expecting? It's a really powerful tool. You can see trends in how your deployment is being used. I've worked on customer cases where the customer had been maintaining months or even years of logs saved off to a side store, and then they share those with us. And it's really powerful when looking into performance problems to say, what was your performance like a year ago when you said it was good? And what is it looking like now? And we can see what's changed, and then we can make educated decisions about how we want to make improvements moving forward. One of the key things, which I'll be touching on in my adjusting knobs, is workbook performance. And with Logshark and the example I'm going to be showing here in just a moment, you can actually see what are the most popular workbooks, but also how do they perform? Are there outliers? Are there patterns? And then using that, we can learn if there are workbooks that need more attention from us. So here's an example of a Logshark output file. And this is from a customer, so I do want to say that on the left, you'll notice the top workbook names are single letters, not terribly exciting. That is just anonymized. You would get full workbook/worksheet name. We give you more information than just a letter. So on the left, we see what are the most popular workbooks. And this is about 2 days worth of data. And we can see that the most popular workbook that was loaded here was actually loaded 16,000 times in 2 days. So a lot of people wanted to see this. On the bottom right, we do a breakdown by hour. And we're doing kind of like a filled bar chart where we're coloring if there were any errors or not. And in the top, we actually have a scatter plot showing every single load of every viz on Tableau Server. And if you had a question about one of those outliers and you hovered over a mark, you would get a tooltip telling you the user who loaded it, what machine it was loaded on, the name of the workbook. So you get a lot of detail, and you can investigate outliers, patterns. You can see when is busy times on your server and when aren't. Now, if we were doing some investigating there and we saw that there was a particular workbook that was troublesome, or a user had called us and said, the performance on this dashboard just isn't where I need it to be, we'd want to turn to a tool like the Tableau Performance Recorder. So it's great, like I was saying, for a single workbook performance. What you actually do is you, via the menu, start a performance recording. You can then load a viz, interact with a viz. You stop the recording. Tableau thinks for a little bit and then creates a TWIBX for you. So it's available for desktop, server, and even on Tableau Online. And the output, again, we came up with this great UI called Tableau Desktop, and it's very helpful. So at the top, you start with a Gantt chart of what's everything that Tableau did in the time that you were doing a recording. The middle pane sorts those by duration, because in any performance investigation, generally the thing that took longest is the thing you want to fix. So here, I saw that my query took 3.2 seconds, and maybe that was of concern to me. So by clicking on the bar in the bottom pane here, I actually get the exact query text. So then, for this live connection, I can decide to go ahead and pick up the phone and chat with my DBA, and I can share with them, here's the exact query that I sent you. And then they can work with you looking at logs in the database and on their side. Another great thing in here is, as I said, it's creating a Tableau workbook. So you can actually just save this as a TWIBX and either save it for yourself to compare after you've made changes to the workbook, or if you are working with support or a sales rep, you can shoot them a copy of this, and they're going to be familiar with the format and be able to take a look and help you out. So I just want to go ahead and talk a little bit, or summarize the tools that we talked about here for doing the initial investigation to see where our performance is. We started with Task Manager, something we were all familiar with. Then we moved on to Perfmon, giving us a little bit more detail, allowing us to do long-term recording. I chatted about Tabmon, which allows us to get the value of Perfmon from all of our machines, aggregate it into one place, and really compare it to what is Tableau doing at those times. I shared Logshark for taking zipped logs and creating dashboards with them that you can use internally or share as needed. And then we touched on how do we look at the performance of a single workbook. Now that we've done all of these things, we have a feeling for where is the performance issue going on? Is our entire server pegged? Is it just that one critical workbook that's not moving as fast as we need? Or is our usage up substantially compared to last quarter? Now that we know these, the real question, and I'm guessing why most people came here today, is what can we do about it? So at this point, we have a mystery in our hands. We have some hints as to what's going on and what we need to do to fix it. So there's a whole host of knobs, and that's what I want to talk about next. So here, I have a list of some of those knobs that I'm going to be talking about. We're going to go through each of them one at a time. And actually, I have a great picture from not long ago. I was doing an on-site at a customer, and I was working really hard, just turning my knobs, making sure everything was on point. And this can be a lot of work, and I spent the whole day there. But it's really great at the end of the day to know that they were satisfied and everything was better than it was when I got there. Oh. And there's one more thing before we get to the knobs that I want to talk about with everybody, which is grocery stores. Before we continue, I want to posit that Tableau is actually a lot like a grocery store. And again, for the hand-raising activity, who's been in a grocery store? Excellent. Everyone's hands going up, and that makes sense. And that's why it's going to be a really good analogy moving forward. So when you go into the grocery store and you grab your cart and you're starting to head down the aisle, that's kind of like you rendering a viz. You're going to start going down the different aisles. You're going to grab a query in the freezer aisle. You're going to pick up a map in the bakery, and you're going to pick up a couple colors out of the produce section. But then it's time to check out. When you get to checkout at the grocery store, there's only so many cashiers. But at the same time, you're sitting there, you have your cart, you're full of stuff, it's time to check out, but you're not the only person in the grocery store. There's a lot of other people, and they have a lot of other carts, and they're all full of different things. So Tableau is trying to process all of these grocery carts full of different content, trying to essentially check you out and get you on your way. And that's rendering the viz and you moving on, making insights with your data. So also you can think a little bit making the analogy over to processes, that each of these cashiers is like a VizQL process that can handle all of the parts that go into making a viz and then moving forward with it. All right. So the first knob I want to talk about for server design, for server performance improvement, is actually workbook design. And I'm guessing at least one person here is thinking, I came to talk about server performance. Why are we talking about workbooks? As you saw in that Logshark demo, we had a workbook that was loaded 16,000 times in 2 days. So making an improvement of 2 to 3 seconds is actually a lot of CPU time. And that workbook, I don't know for that customer, but in most customers, it's usually called quarterly sales attainment. And that's because every salesperson's bonus is totally dependent on the data in that viz. And the last week of the quarter, they're going to be loading that viz tens of times a day per person, if not more. And I'm guessing everyone here in their business has a viz with that name. So some of the tips to get things moving is reduce the number of filters as much as possible. I want to make it clear, I'm not saying don't use filters. It's a critical part of making a dashboard. But every additional filter you add creates more complexity and makes the queries that you're running against your database be more complex. You want to ask yourself also, how many marks are effective and worth having? If you have, say, sales transactions, and you have millions of marks, Tableau runs a query, pulls all that data back, and then it has to draw, let's just say we're doing circle marks, something simple. It's going to go draw a million circles. It's going to shade them in. It's going to give them backgrounds. That's a lot of marks. And a high-end laptop monitor might only have 5 million pixels, and those marks take up more than 1 pixel, and we have to compute transparency. You're not actually gaining a lot of value. There's a lot of clutter, but that's a lot of extra work for Tableau. So if possible, think about, are there ways to aggregate the data, maybe by region, by product type, by salesperson, where we're not losing any insight, but we're reducing the number of marks. And from the keynote today, as they mentioned, something like a heat map could actually be very good if you think you have a scatter plot that has a very large number of points. A heat map reduces that total amount of computation of what Tableau has to render and then put on the screen. Another thing that you always want to avoid is massive crosstabs. And a story I have about crosstabs is first to consider that it's like a table of text, essentially. And each cell has about a word's worth of information. Maybe it's a number, maybe it's actually some words, an address, a name, but it's like a word. So I came at a performance case, and the customer called me and they said, Jonathan, can you take a look? Our crosstab dashboard is performing horribly. They had about 8 columns. That seemed reasonable. Fits on a screen, even on my laptop, no problem. Then I looked at how many rows they had. And they had 5 million rows. And this was in their default view, not like if you went and selected all and a bunch of filters. You load the URL, you get 40 million cells filled with information. So not only is this all being queried, the strings are being rendered, and they're being put on the screen. And the customer said, no, it's important. I need all of this every morning. And I did some thinking, and I went on my favorite search engine, and I looked up the Lord of the Rings trilogy. It's about this much book, I'm guessing, and it's 480,000 words. So this person was rendering approximately 100 times more data every morning than that series of books. And so I explained this to them, and they understood. And what we did is we put a couple of filters up at the top that were relevant for the different salespeople that needed the data. And instead of trying to look around, you came in, all of the filters were set to null. There was actually an empty crosstab, not terribly exciting. And then the salespeople could go select the things they were interested in and hit an apply button. Then whatever rows actually applied to them that they wanted to see got rendered. So we didn't actually reduce the data available in the dashboard, but we reduced the fact that every time it was loaded for the first time, we're loading 100 copies of The Lord of the Rings. In some of my later slides, I'm going to be touching on tips for this, but the more broadly we share a workbook, the more optimized we want the data source to be. If you have, again, using that quarterly attainment dashboard, if you want to see how your sales been this quarter, you don't want every time that the workbook is loaded to sum every transaction of your business. Especially if you were some sort of business that has storefronts with cashiers, that could be tens of millions of transactions. Instead, it might be better to optimize it to pre-sum that data and have it in a format that's ready, that's ready to make the viz you want. So if you're looking at sales by day in the quarter, that's only 90 rows of data to pull in. So that's a big improvement. Now, this is a huge topic, and I don't think we're going to all become experts on workbook design here today. So two things I want to say is we have a great white paper called Designing Efficient Workbooks. The URL for it is here. You can also go to any search engine and type Tableau Designing Efficient Workbooks. It has tons of information about all sorts of different vizzes and gives tips. Additionally, there's a session dedicated just to this topic on Thursday, and the last slide of my talk has recommendations of other talks, and that's going to be on there with all of the details with the room and the exact time. Moving on and touching on that, keeping your data sources efficient filter, or that topic, sorry. I want to talk about database design. So this is in the realm when you have vizzes that are using a live data source. So the first thing, actually before my first tip, go meet your friendly neighborhood DBA. I'm sure they're nice, they want to meet with you, and they're going to want to help you to reduce the load on their databases. The first key thing you may want to talk to them about, and that you will have insight into what is needed maybe beyond them, is indexing on the key dimensions that are of interest. So for those of you not familiar with the concept of indexing, what this essentially is sorting the data ahead of time by the metrics that are of interest. So again, using the sales transaction example, let's say you sort your transactions by date. That seems pretty natural thing, just the order they came in. If somebody then came to you and said, tell me about all the sales last Monday, you flip to the page, and they're all in order, and you can basically take that snippet and hand it to them. But if later in the day, they come back and say, I need to know all of the sales that happened in a given state, you now have to search all of that data, and you have to hand them many little snippets and put them together. Indexing essentially provides a pre-sorted list so that when the query comes in, the database can more efficiently answer the question. And doing something like this is something that you will need some help from your DBA doing. Really quick here on the right, I'm going to have a little example of a table of data. As you can see, we have a couple of rows, a couple of columns. An important thing for Tableau is that fewer columns are better. And there's two different advantages. So first, you can see here, I've shaded out the columns on the right, and that's less data being returned from the database. There's a secondary benefit here where Tableau doesn't have to wait to hear back from the database about any information about metadata for those columns. Some data source types actually take a long time to give you some information in the metadata that Tableau needs. So if you have a very wide table and you're not using all of the information, why ask for it? You know, a great example, I work on customer defects. I connect to our customer database to see what defects are active and who's working on them. But that also includes the address of the headquarters of a customer. When I'm fixing a bug, I don't need to know where you're located to fix it. And if I do need that, I'll go get it later. So by calling those columns, my extracts are created faster, my viz is quicker to load. It's a big win. The next thing is to smartly use data source filters. So this is essentially calling out now rows that aren't relevant. So going back to that end of quarter dashboard that we all have, if you were creating that nice 90-day trend line to see how your quarter is looking, you probably want to compare it to the last few years. That's a pretty common thing. But if your database contains data from the last 1 or 2 decades of sales, why pull that in? Why spend the time running the query and having that payload come back? So by applying this data source filter, you can help reduce that payload and make your return on your query faster. For high traffic vizzes, you're going to want to consider materializing your table. And that's what I was talking about earlier with, again, the example of the quarterly dashboard. Just sum your sales by day ahead of time. And this is something you'd work on with your DBA. But have the summed sales by day in a separate table. And when you create your viz, connect to that table. So now instead of having, let's say, 10 million transactions for a grocery store, national chain in a quarter, you have no more than 90 rows because your quarter only has 90 days. So that query is going to run way faster. It's going to be way nicer. Now I want to move on to talking about Tableau extracts. So the biggest win with an extract is we've gone to our data, we've already called our columns, we've applied our data source filters, but now the data is local. With a live data source, we kind of don't know ahead of time where the data lives. Ideally, it's in the same data center as your server, but maybe it's not. Maybe your business has multiple data centers, or you're connecting to a data source that just doesn't happen to be local. You also get to only keep the data you care about. Those calling of columns and rows is applied when you create the extract. So you're only storing the small amount that you actually need, so you save on performance and on hard drive. You reduce the load on your live databases. So before, we were doing a live connection to the database every time somebody loads a viz. That database might be used by other non-Tableau applications that are interested in the same data. It could be that there's new data being written to that data source constantly, and now you are competing with that. So by doing an abstract, you essentially run the query once, and you save it all locally, and you're good to go. You also can hide some fields or rows that you want to keep private using hide unused fields or data source filters to keep out data that you don't necessarily want everybody to see. Another big advantage is materializing your calcs. And as you saw, my little beige, small rectangle of data that we are keeping got a little wider. And you might be thinking, we just spent all of this time making the data smaller. Why are we making it bigger? That's counterintuitive. But if you have a lot of really complex calculations, this can be a nice win. Think about any big string calculations you have, or those nested LODs that you need to get your work done. By materializing the calculation, by essentially optimizing your abstract, Tableau goes ahead and pre-computes all of those values and has them ready to go. Because after you take an abstract, the answer to any of those calcs isn't going to change until you refresh the abstract again. So basically, we take the time, we compute every possible calculation value, and then store it locally. Speaking about abstracts, I want a quick aside about Hyper. Can I quickly get a show of hands for how many people are on version 10.5 or beyond? Excellent. So I see most hands up. I'm glad to hear it. So a couple of points I want to touch on, starting with that hyperizing happens at refresh time. So this really applies for the first time you've gone from Tableau 10.4 to anything beyond. So if you took your abstract or a backup, in Tableau 10.4, you set up your test environment in 10.5 and you restore your backup and you start doing some performance testing, some UAT testing, you would very quickly pick up the phone, call me and say, hey, Jonathan, we upgraded to 10.5, we're really pumped for Hyper, and the performance is the same. You're going to sound very disappointed. So what actually happens is that first time you restored your backup, we kept all of your abstracts as TDEs. And the reason for this is that we heard people don't want their recreation of their backup to take days. If you have many, many abstracts and we had to go through each of them, converting its format, that would be a lot of computational time. So what actually happens is the first time that Tableau Server refreshes any abstracts in Tableau 10.5 or beyond, it converts it to Hyper. And from then on into the future, you have a Hyper file. The TDE is gone. And don't worry if you have something that isn't refreshing or it only refreshes once a month. Hyper has a built-in data engine reader and can read the old format just fine for all of time. You can still materialize your calculations with Hyper. This was something we got a lot of questions about. It was a popular feature with the old Tableau data engine or TDE format. That functionality is still there. We see a lot of perf improvements in Hyper. So here on the right, we see a scatter plot of some performance testing done by our Hyper team in Germany. What we see is along the x-axis, how long were these sample queries taking? And on the y-axis, we see the multiplier of improvement. The results are then colored, so green are what we felt were good improvements. Yellow were things we felt were pretty neutral changes. And there are, if you look very closely, okay, you can even see it on the projector, there's about 5 marks that were a little bit slower, and they took about 5% longer. I do want to point out for the ones that are slower, those were queries that were already taking less than 0.05 seconds. So if you go from 0.05 to 0.0505, you're okay. We're keeping it under that threshold of perceptibility, and for the most part, we're seeing these improvements. And we're continuing to work on Hyper, making it more integrated into the product and have more improvements in the future. Another exciting thing is we have automatic deployment of the processes. So how many Tableau admins here remember on Tableau 10.4 before having to decide where to put their data engines? Right? I see a hand in the back, and you had to decide how many data engines to put and where. So with Hyper, that problem is gone. Now, as you deploy Server, Tableau sees where you put other processes, and then based on that, puts a Hyper process in place with all of the backing that it needs on those machines. Now, there's also some questions. We solved the problem of you don't have to worry about where to put it. But some people did want to worry, and they wanted to put it on separate dedicated machines so that running hyperqueries doesn't impact performance of things like loading vises. So in the beta that they announced in the keynote this morning, we're offering functionality where you can isolate Hyper on its own machine. And if you're interested in doing this, go to prerelease.tableau.com. You sign up to be a part of the beta program there, and you will get further instructions. And so with this, you can actually take Hyper, as I was saying, run it on a separate machine. either just to separate it or to run it on a much beefier piece of hardware if that's what you choose. Now, I want to talk about the Tableau topology. And so what I mean about this is, where do we put the processes that make up Tableau Server, and how do they talk to one another? And I'm going to share some stories from customer cases. So the first one I want to talk about is keeping your workers local to one another. So real quick, how many people have a multi-node server environment? All right, I see a lot of hands. So if you read the documentation, I believe the exact verbiage is something along the lines of ensure that all of your workers are on the same subnet. And that's so that the latency between the workers is low because there's a lot of crosstalk between the machines. But I want to tell a story that goes beyond subnets. I had a customer case a few years ago where they called me, and they were saying that our performance is great about 2/3 of the time, and we're not sure what's going on. So they sent me their logs, and I actually used the same dashboard you saw for Logshark, and I noticed that a bunch of really nice loads, 1 to 3 seconds, and then another band just totally separate of 5 to 6 seconds. And you could see the white in between them in the background. It was a clear bimodal distribution. And I did some digging, and I thought maybe there's something different with the hardware, something's wrong. So I put worker number on color, and then the marks all changed color, and the much slower bar was all one color, and it was worker 2. And so this customer, they were based on the East Coast. For their anonymity, I just put the dot roughly where I live. But they're an East Coast-based company. That's where their data center was. And I called and said, OK, well, what's up with worker 2? It's definitely slower than the others. All the bad loads are there. They reached out to their IT team, their VM team. It turns out, despite also being on their corporate network, worker 2 is in the Netherlands. So yes, they were all on the same network, and they could talk to one another. But you did have to send your query for your request for a query through the transatlantic cable to Europe, get an answer, get it packaged and sent back over before you got your dashboard loaded. So we worked with them, and thankfully it was a VM deployment, and they had VMs on both sides of the ocean. And we were able to spin up a new machine and move worker 2 to be a little bit closer to its friends. Another tip that I like giving, and this applies primarily for Windows servers, is opening up your ephemeral ports. So if you're running on Windows Server, you actually only have about half of your ports open by default. And this is a security feature. If those ports aren't being used, there's no point in making them accessible externally. So here I have one of those links that's just nasty text with a lot of alphanumeric fun. So this is a hyperlink. It'll be available in the talk to download and go. It's to Microsoft documentation on the command line arguments that you run as an administrator on the machine to open up the ports. And this is helpful when you have a multi-node environment for the Tableau processes to talk to one another. So VizQL asking a question of hyper in another box, or accessing something from the cache on another machine. Another big and very common thing that we talk about is backgrounder isolation. So I'd noticed not everyone's hands went up for the multi-node environment. And in that case, it means that you have VizQL and backgrounder running on the same machines for sure. And so this can be OK if you don't have too much load on backgrounder, or in my session earlier today, somebody was telling me their company is actually very good that you can only schedule extracts at night. So they all run overnight, but by the time people come in the morning, they're refreshed and we're good to go. Isolating, though, could be a big deal. There's some customers that basically don't allow their users to have live connections. And there was one customer I had where when they reached out to us, they actually had 50 backgrounders at the time. And they were running constantly. If you used either the admin view or Logshark, it was basically a Gantt chart that was just a solid line. It was just a big brick of jobs. And that was great. And so we worked with them to figure out what is the appropriate number of machines that they needed to support the load of extracts that they had. So that, as an extreme example, you want to be sure to isolate and separate. And kind of one analogy to think about here is you have two basic behaviors happening here. One is backgrounder, it's sending a query, it's creating an extract, it's going to be great. The other one is there's somebody at their desk sipping their coffee, watching a spinner. And if those two jobs are competing for CPU, that's not great. But by isolating the backgrounder, maybe all of your backgrounders together are going to be a little bit slower and your extract's going to arrive, let's say 30 seconds late. But would you rather have your extract be 30 seconds late, or have your VP sitting there sipping their coffee for 30 seconds watching a spinner? This is a decision I leave to you. Oh, and I did want to say, I should have brought this up a second ago for the backgrounders. Here, with that example, we saw in Tabmon before that spiky backgrounder behavior is the CPU getting eaten up on a regular schedule. So moving that off to another machine is going to make it smoother. Also, I forgot to mention, sorry, again, in the backgrounder, you can have about one backgrounder per core. It is a single-threaded process that's running queries. Once it gets the query result, it's creating a hyperfile. Now, there are other processes like VizQL and Data Server, which run massively in parallel. VizQL is trying to handle all of your requests to make vizes, be it one person accessing server or tens of thousands of people. So you do want to leave a little bit of breathing room on the cores there. So for things like VizQL and Data Server, the kind of rough rule that we give to start with is don't have more than one of those processes for every 4 cores on a given machine. Another thing that I've seen when coming in and working with a customer looking at their topology is lots of cache servers. People love cache because cache means I don't have to run my query again. The way they choose to solve this is having 16 cache servers on each box. Turns out that that's not necessarily the best way to go about it because the caches by default have a certain timeout value and a certain size. And by having 16 of them, they all have the same timeout, so any value that gets entered still gets wiped after a certain period. But also, you can't actually fit anything bigger in there if you're running any large queries. I don't want to get into all the details now, but there is, on the Tableau documentation, settings for how do you make that timeout longer so the cache value stays in there longer, or how do I make that cache even larger? The only thing to consider is that that cache can use that memory and hold it for the length of time that you say it's there. And just so you know, if your cache ever does fill, the old queries get booted out. It's essentially a first in, first out algorithm. So just as new things come in, they push out the old stale items. The next topic I want to touch on, which is near and dear to my heart, is VM resource allocation. Can I quickly see a show of hands? How many people here are running Tableau Server on a VM of some sort? All right, I see most of the hands that went up. Awesome. So at Tableau, lots of our customers use VMs. But it's important that we configure them in the right way. So when you're working with your VM team to figure out what settings do you need, how many machines do you need, just keep in mind that Tableau is, pardon me, a compute-heavy application. And maybe your VM team isn't familiar with Tableau, and it'll be good to give them a quick reminder. Because remember, we're not just drawing a picture. We're optimizing queries. We're creating extracts. There's a lot going on. So you want to make sure that you're appropriately reserving CPU and memory so that Tableau has the resources to quickly do the jobs it needs to do to render your vizes, to create your extracts, to send out your subscriptions. VMware has a great white paper. Again, pardon the link available with the download of the slides. They have a great white paper that talks about supporting latency-sensitive applications. And they actually recommend, for those processes, make sure that they have 100% CPU and memory reservation. Now, a quick thing I want to touch on in case not everybody is familiar with VM terminology. Reservation doesn't mean I'm reserving this amount and nobody else can use it. And because when we moved to VMs as companies, part of the reason was to share resources. When I'm not doing something, I want my email server to be able to come in and do work and whatnot. So reservation in this scenario is actually just saying preference. So when you set this CPU or memory reservation, what you're telling the underlying system is when Tableau needs resources, it gets preference on this amount that we're giving it. And yes. So we actually did an experiment to look into how does adjusting CPU reservation affect performance. So as I mentioned before, one of the metrics we use is transactions per second. So you can think of this as a rate of how quickly do we load vizes. So the experiment we did is we took a single VM host and we put 2 VMs on it. The first one had Tableau Server, and we were going to be running some performance tests on it. The second one had a bunch of hardware testing tools that just chew through CPU, memory, writing stuff to disk, just being that heavy, nasty VM neighbor that we've all seen. Then what we did is we started perf testing Tableau. At first, we did no reservation. Then we did 5% CPU reservation and slowly cranked our way up until we hit 100%. So I'm going to show you the results here in a minute, but I'm curious to see what do people think. How many people think there was a linear relationship? So choice A, where, yeah, I slowly increase my reservation and my throughput per second goes up roughly the same. OK, no hands. How about B, where there's, at the beginning, not a lot of change, and then the more CPU I get, the more ramping I get? How about choice C, It's kind of an S-curve situation where the more you get, there's an inflection point. Okay, I see a few hands. How many people think choice D? Doesn't matter how much I reserve, I get full throughput no matter what. I see one hand up. A little bit of an optimist. That would be great, and that would change the whole nature of my talk. So behind me is what the actual result was. It was pretty close to choice C, where we have this nice S-curve behavior. Now, you can see there's an inflection point, and there's kind of a point of diminishing returns. But there's actually an important detail I want to show here. All the way on the y-axis, look at where the line hits. It's not at 50%. You would expect if you have two VMs all trying to do a bunch of compute-heavy activities, you're going to get a 50-50 split. That's kind of what I would expect. But it turns out VMs actually have to do a lot of context switching when it's going between allowing one VM to do work and the other. We're clearing out the memory. We're swapping things out on the CPU cache. There's some work that has to be done. And so you actually only get about 34% of the throughput that you're paying for by doing no reservation. So I just wanted to share this to motivate you to see that this curve really does matter and that reservation can make a difference in the performance that you see on your server. All right. The next topic I want to talk about is antivirus. On the right, you can see a picture of some of my friends who are developers for antivirus, and you can see the speed at which they like to work. All of us have AV in one way or another. I have it on my laptop. We all have it on the servers at our company. It's policy. I want to make it clear, I'm not recommending that anybody here find a way to violate their company's policy and remove antivirus. What I am saying is that we need to find ways to have it work along with Tableau. Just like for the discussion with our VM team, we have to remember Tableau is latency sensitive. And there's kind of two facets here. There's, if the antivirus is doing an active scan, it just takes up resources. It's reading files, it's looking at the contents, making decisions. There's also another scenario where antivirus can act as kind of a filter driver. And I actually had a customer once, we had this performance problem. It took us far too long to work on. But what it ended up being is they had a filter driver that was running to make sure that any third-party applications trying to access DLLs from the Windows file path, well, we need to check those to make sure those aren't viruses because those could be quite harmful. However, the DLL that was being protected was the one that allows Tableau to read files off of disk. And I'm not supposed to talk about proprietary Tableau technology, but we do read files off disk for our software to work. And so every time we had to do almost any action, including loading vises, which are essentially XML files stored on disk, we were getting stuck in a queue behind other jobs, waiting for the filter driver to give us the thumbs up. So to help work around this, we suggest having exclusions for the Tableau and Windows directories if possible. Then, as I was mentioning earlier, we have active scans that go on, and those are unavoidable and add value, but try to schedule them at the off hours. So either you intrinsically know that you don't have users at a certain time, or you could use a tool like Logshark or the admin views to see, yeah, most of our workers are at home by 2 in the morning. It's a pretty safe time to run the active scan. And if you run a global organization, maybe you want to look more at the weekends to find what is that lull, because there will be a performance impact. But if you're having that at a time with fewer users, there's going to be less contention for resources. The final area I want to touch on is planning for growth. And this can come in a whole host of different forms and is tailored to what's happening in your organization. Because your growth can be more users are coming online as you're hiring and growing as a business, or maybe you're just bringing new departments in on your Tableau server. You could also have developing user engagement. So maybe Tableau was new last year and you had a couple of those enthusiastic early adopters. But today, teams are making Tableau an integral part of their process. So your actual licensed users, it's the same number, but they're just doing a lot more. And then, of course, as time goes on, you're going to start having more power users, and they're going to be creating those really rich dashboards that might be doing a lot of work. So using things like Logshark to see, is it more unique users that are logging in? Is it more views per load, more views per user, or other metrics like that allows you to make a decision, what is it that we need to grow? Do I need to go isolate backgrounders now? Do I have the same number of loads but just a lot more extracts, and I need to move it? These are all decisions that you need to make based on what you're seeing in your own environment. As I mentioned, yeah, Logshark and the admin views can give you some hints on where you should be going. And these, yes. Another thing, if you need additional help, feel free to reach out to your account reps. If you have contacts in Tableau support, these are all great people who are familiar with all of the tools that we've talked with here. They're going to know how to look at the results, how to interpret them, and help guide you in rearranging the server you have now, growing your server, or helping you optimize the content that you have here today. Really quick, I wanted to give a summary, just to remind you, here's some of the knobs that I talked about for changes we can make. And I don't expect that any of us became experts here in the hour we've had together, but I want these to be in the back of your mind. So next month, next year, when you do see a performance problem, you can think, oh yeah, I learned about these things, they're out there, and you can come back to the recording of this, you can look in Tableau documentation, but you have a feeling inside about where to go and get started. Now really quick, I want to say I'm looking at the clock, we have about 9 minutes left. So I want to do some Q&A, and then when we have about 2 minutes left, I'm going to have some closing thoughts, and Ventura's going to wave at me and get my attention to let me know it's time to wrap up. Yes? So the question was if isolating backgrounders is the same as isolating hyper, and it is not. Those are two separate processes. So backgrounder does the scheduling and handling of some of those queries. You can move hyper to be with it, or you could have an isolated backgrounder and an isolated hyper next to it. Yes? I anticipated that question. So the question was, how much of an impact is prep conductor going to have on? Mm-hmm. Mm-hmm. So the question was the performance impact once you're running prep conductor on server. And so this is unfortunately a difficult question because like creating a workbook of arbitrary complexity, you could create a flow of arbitrary complexity. And so the thing to consider is that essentially the prep conductor is going to be doing the data cleaning and joining and then creating a number of extracts. So it depends on the complexity, but it's similar to creating an extract containing that data. So the follow-up question was if I recommend isolating prep conductor. I don't yet have insight on how it performs at large scale to answer that. Let's go ahead.
The question is 2019.1 is out.
So the question is when will prep conductor be available?
It should be out now.
So I believe it's in beta now.
I know, that's what I'm saying. You should
Oh.
actually start loading. It's available for download now.
Yeah, so he was saying that since it's available for beta now, you could always put it on a UAT type environment and start testing. In the back, yes?
I know Tabmon to be useful in Windows, but what is available now for Linux?
So the question was that Tabmon is useful in Windows, but what about in the Linux environment? And so at this time, we don't have Tabmon for Linux. I've been chatting with the people who are on the team that created Tabmon, and that's something that is on their radar that they want to work on, but we don't have something right away. Do you have a follow-up?
Yeah.
Okay.
So I see you talking about planning for growth. You didn't mention Tabjolt load testing.
So the question was, I didn't talk about specifically load testing. So there's a separate talk, and actually, I'll jump to it in a moment. So my last slide includes, actually, let me see if I can jump to it. There are 2 talks that I recommend people come to here. So there are 2 talks I recommend people go to later in conference. They're both on Thursday. The first one is that designing efficient workbooks that I mentioned. The second one is capacity planning and load testing with Tabjolt. So those are both on Thursday, and they don't overlap like last year when I made this recommendation, and that was unfortunate. So that will be a great talk to go to, and the 2 speakers will be able to help you a lot there. Yeah?
Workbooks which have huge data extracts, the extract is going away because of the limitation that we have on the server. So if I do a live connection to that databases, how does cache servers come into picture? Does it still cache some of these same queries that slicing and dicing happens with the end user? How long we can keep that if it is a live connection?
So the question was that today they have large extracts, but if they connect to the data sources as live, will cache servers still play a role? So Cache Server will still cache queries from live connections. The default timeout, I believe, is 30 minutes. You can go in and change that, but even with the 30 minutes, if you have a lot of new queries coming in, as it fills up, it will push out the old ones. There's no current way to say keep this cache indefinitely and forever.
Is the scope, can the scope of the cache can be at the site level, or is it global?
So the question was if we can keep cache settings such as timeout and size to site level, and unfortunately this time we cannot. It is kind of global to the server.
Is that something you guys have been doing?
It is not something I currently know about. Go ahead in the back.
Yeah, my question is around workbook performance. I have one specific workbook that leverages nested LOD calculations, and I can't use Optimize or any of the sort of native Tableau desktop functionality to optimize those calculations. It renders a lot of marks, and ultimately, basically I'm looking for some sort of solution to cache every combination of results. It's refreshed weekly to run some sort of background task to cache every combination of results. Does anything like that exist?
So the question was, is there some way to pre-cache large combinations of outputs? And correct me if I'm wrong, this sounds kind of like a cache warming type scenario. So there's no built-in cache warming. What we have helped people do in the past is you can try to write a script that just loads the viz in the background with any, let's say there's specific parameters you were interested in, but that cache is, at least by default, not going to stay very long, just because we can't keep the cache indefinitely full. So there's not a current way to like keep cache hot long term.
So do you have detailed documentation for the cache server manages the, is it first in, first out?
So it is first in, first out. I don't know if we have a specific white paper that walks through the internals of the cache server. Why don't you stick around after I can give you my contact information, and I can go reach out to that team. Yes?
Is there a way to kill off major offenders? You mentioned that there had people that were using workbooks that took a long time to perform queries or whatnot. And you have a lot of those where you kind of like start by using them. Is there any way to look at real-time solutions, perhaps link them to jobs that are taking really long?
So are you talking about, so the question was about killing offenders as far as like resource utilization. Do you mean specifically like a given workbook that's taking a long time to load, or do you mean like we notice this VizQL process is chewing through, say, CPU or memory?
More specifically as a user, right? Because it seems like that VizSQL process can be serving multiple users versus when you kill off just offending users, you don't impact those.
So there's no current way to like through the admin view, kill off specific sessions. You can look and see with a tool like Logshark which users were creating those really long loads, and then you can reach out to them, or you can potentially like pause their content. But there's no like way live to see this was taking a really long time. I'm getting the signal from Ventura that I only have 2 minutes left here, so I'm going to be sticking around afterwards to take questions. A really quick thing, I do want everybody, please go and complete the survey in your TC app about this session. The ratings let us know what talks were popular and that we want to re-give. And the written feedback I really appreciate, so I can improve this session going off to the future. Thank you all for coming, and enjoy the rest of the conference.
Thank you.